This is a continuation of the answer to practice question 5 from the week 2 practice questions. In fact, I'm going to be doing answering part C here. In part C of the question, we are told that y, a random variable, is distributed as the chi-square distribution with degrees of freedom of 10. The first part asks us what is, it says, if we know that the probability that this random variable y is greater than a specific value y, that probability is equal to 0.05, so in other words 5% chance of that happening, what is the value of y? It's the specific value of y. Now, to answer this, we'd have to decide which function to use. Here's page 2 of the handout from class discussing these Excel functions, and we're looking at chi-square. Oh, mistake, chi-square. And in this case, we are looking at this. No, not this one. It's this. It's the second version that we're interested in, the inverse function. Here we know a probability, 0.05, and in fact we know that probability, and we're trying to work out this x value, or although it's called y in our particular question. So flipping back here, the chi-square distribution looks something like this. We're trying to, here we're saying that y is measured along this axis, and we're looking for a particular value y for which the probability of getting greater than that value is 0.05. So this in Excel will be equal to chi inv, the probability that we're interested in. If you look at my diagram on the other page, this is the area that, or the probability that Excel wants to know, so 0.05. And the degrees of freedom is up here, 10. So we will put that into Excel, and that produces an answer by my reckoning of about 18.307. Part 2 says what is the percentile rank for y is equal to 12, and this is equivalent to saying what is the probability of a y-score being less than 12. So we're interested in something like this. We've got y being measured along this axis, 12. This is the chi-square distribution, and it has degrees of freedom of 10, which define the exact shape of the curve, and we want to find this probability which is equivalent to that area. To do it, we're going to use the chi, but pronounced chi, dist function, but that is going to tell us this area here. But if we want to know this area and we know that one, we'll just subtract this area away from 1, and that will be our answer. So our answer is going to be equal to 1 minus chi dist, and if you were referring to that formula sheet, to use that function, Excel wants to know the x value, so that's the specific value 12 in this case, and the degrees of freedom, which is 10. Plugging that into Excel, you should get an answer of about 0.7149. Part 3 says, is the variable y symmetrical? Clearly it's not symmetrical. And does it exhibit positive or negative skew? Well, the way I've drawn it, there's a longer tail out here to the right, heading towards the positive values, or large positive values, and that means that this has positive skew. So a long tail to the right is positive skew. What are the mean and median of y? Well, to answer this question, the mean, I gave you another handout in this week's class which summarised the various theoretical probability distributions, and that is what you'd want to look at here. If you looked at the chi-squared distribution section, it says that the mean of this distribution is in fact just equal to the number of degrees of freedom. So in this case it will be equal to 10. And then the median is actually the score, let's call it y again, such that the probability of getting a chi-squared value less than that specific value y is equal to 0.5. So with the median, there's a 50% chance of getting below it, there's a 50% chance of getting above it. So in fact, I could write this, but I could also write that the median is the y value such that the chance of getting a random variable greater than that y is equal to 0.5. Now that is in the exact form that the chi-inv function that we've seen previously wants to know probabilities. So to get this median, we are going to, in Excel, type chi-inv. That function wants to know the probability to the right of the value that we're interested in, that's 0.5. And it wants to know the degrees of freedom, which is equal to 10. And if you do that, the answer that you should be coming up with is about 9.34. Part 5 says, how do the values taken by y relate to the standard normal distribution? Well, looking back at that summary of theoretical probability distributions, which I gave as a handout in week 2, it says that here it describes V as representing a chi-square variable, and it says that that is equal to the sum from I equal 1 to I equal, in mine it says m, but in the textbook it will say k. This is just the degrees of freedom for this distribution. So sum that many instances of a standard normal distribution value squared. So in other words, to get a chi-squared random variable, you have to select the number of degrees of freedom values from the standard normal distribution, square each of them and sum them. And when you repeatedly do that, you end up with a distribution which is distributed as the chi-squared distribution with k or m degrees of freedom. And that is a solution for question 5.